So you have asked this homework question that the intensity of illumination at any point is proportional to the square of the reciprocal of the distance between the points and the light source. Now two lights, one having intensity 9 times that of the other, are 11 meters apart. Now on the line between the two line sources, how far the stronger light is, so that how far from the stronger light is the total illumination least. Okay, so if we look at a picture, say here is the stronger light and here is the weaker one, and here is the point, and we are say at x meters from the point P. All right, and if we go by this rule that the intensity is proportional to the square of the reciprocal of the distance, okay, then the intensity at of the illumination at point P would be this, like say if the intensity here is say 1 over x square, or say this is the intensity here is 9 times compared to the intensity here, so I brought that 9 in, and k is the constant of proportionality. Okay, so our question is that what is the value of x for which this value is a minimum, and of course our interval or the domain of the function that relates to this problem is the open interval 0, 11. You know, x and 11, they can't be in the interval in here. Okay, and at the same time the minimum that I can be with this point is 0, and of course 0 is forbidden. So let's continue with our discussion. Okay, so again we have to find the value of x in this interval, open interval 0, 11, for which this quantity is minimum. So the first thing we do is we just use the reciprocal rule and the chain rule to find the derivative, as we will do in any max-min problem. All right, and then we would find the critical numbers for x in 0, 11, and for that we shall set the derivative equal to 0. Okay, now we shall simplify this by taking the common denominator, arriving here. Okay, which is and then do further algebra. You know, we did divide this equation by 2, and then we want to simplify this. Okay, and when we simplify this, yeah, I mean, just assume I carried out the multiplication and added this quantity x cube here, and this turns out to be a messy quantity. Okay, so let's discuss further and use some other approaches that we have learned. Okay, so again, let's go back to our question that I have to find an x in this open interval for which this is equal to 0, and going ahead algebraically appears to be messy, so we are going to try some other ways. Okay, so let's go ahead and compute the second derivative, again using the reciprocal and the chain rules, and look at these two quantities. These are going to be, see, this is an even power and even power, so this is going to be positive in the interval 0, 11, right? Okay, and at the same, and we can conclude that f prime x, that is the derivative of f, will be an increasing function on 0, 11. All right, and then if we go further, this also shows, or another implication is that f, the function, is concave up in this interval, and which gives us this conclusion that if there is a solution to this equation, all right, let's call it the equation 1. Okay, so if there is a solution to the equation 1 here, okay, in the interval 0, 11, then that's going to give us a minima, right? So let's see if it will even have a solution in there. So what we can do, now let's use Excel to see that whether we shall have any value for f prime x in the interval 0, 11, okay, where this function becomes a 0. Okay, All right, so let's see. So we will just enter that this equals what? Negative, what we got there, 18 over, so we have this quantity to the third power, right? And then we are going to add 2 divided by 11 minus the quantity again, and then we want to raise it to the power 3, okay? And let's close the parentheses. All right, so here is the value, okay? And if we look at that, then notice this, that it changes sign between x equals 7 and x equals 8, okay? And what does it mean? That we will have a solution of the equation f prime x equals 0 between x equals 7 and x equals 8 by the intermediate value theorem. All right, so now we have this, that this equation has a solution in the interval 7, 8, okay? So if we look at it further, we know that f prime is increasing on 7, 8. So this will be the only solution, and actually the only solution in 0, 11. And now you can apply the Newton's method. Just use the initial point as 7.5 and just iterate it. And I think the question wanted an answer up to the 2 digits after the decimal sign. So here we see the sequence is stabilizing. So 7.43 meters, or approximately 7.43 meters, would be your answer. Okay. We can use our graphing calculator to verify our answer. So we will enter the expression here. Okay. And then what we can do is that we can go ahead and ask it to give us, just a second, excuse me. Okay. All right, it's entered. I'm sorry, here. Right, so we want to find the minimum. Okay, so of course the minimum is somewhere here. So we'll say for the left end point 5.5 is okay, and for the right end point we can just take it to the right, and I think, yeah, we are right enough here. Okay, all right. And for the guess, is that this is asking that, you know, it might use 8.95 as a starting point. Now since this has to work, we don't have to do any calculation. We'll let it take that. All right, and here we go. We have the same answer, like x is 7.43 meters approximately. Okay.